Hello students, in this video I will teach you a very important topic from the complex number system known as the Moivre's theorem. Let us see the basic idea behind this theorem. If we have any number z, either complex or real, and we take integral power of this number, then what should we get? We get a unique value. But what happens if n is not an integer? That is, n belong to set of non-integral rational number. Is the value still unique? No. So based on this idea, de Moivre gave two statements, particularly known as de Moivre's theorem. Let us see those statements. Let z be any complex number, then z can be represented as r cos theta plus iota sin theta. Polar representation of a complex number. Here, using de Moivre's theorem, we deal with those numbers that can be represented as cos theta plus iota sin theta only. Now, statement first. Cos n theta plus iota sin n theta is the only value of cos theta plus iota sin theta whole power n when n belong to set of integer. And the second statement is cos n theta plus iota sin n theta is one of the value of cos theta plus iota sin theta whole power n when n belong to set of rational. See, when n belong to set of integer, then cos n theta plus iota sin n theta is the only value of this. But when n belong to set of rationals, then cos theta plus iota sin theta whole power n has more than one values, in which one of the value is cos n theta plus iota sin n theta. Here what we are doing, we are just multiplying the power with the angle theta. Now let us see the proof for this theorem. Proof. We know that from Cauchy-Euler representation of a complex number, cos theta plus iota sin theta is equal to e to the power iota theta, right? This is equal to cos theta plus iota sin theta whole power n is equal to e to the power iota n theta. This is equal to cos n theta plus iota sin n theta. This is the proof for this theorem. Now let us move to solve a question based on this theorem. Question. Solve 1 plus sine 2 pi by 9 plus iota cos 2 pi by 9 whole divided by 1 plus sine 2 pi by 9 minus iota cos 2 pi by 9 whole cube. See, this is a complex number and we are taking integral power of the complex number. Then we get a unique value. So our aim is to find that value. See, can we use de Moivre's theorem here directly? No, we cannot use, because this complex number is not of the form cos theta plus iota sin theta. So what should we do? We have to convert it in this form. So to convert it in this form, what should I do? We can rationalize it and solve them. But rationalization is very lengthy process. So we can use one identity here. What are the identities? See, a plus iota b into a minus iota b is equal to a square plus b square, right? So this implies that a minus iota b is equal to a square plus b square upon a plus iota b. Can we use it here? Yes. So using this here. Now 1 plus sine 2 pi by 9 plus iota cos 2 pi by 9 whole divided by 1 plus, keeping numerator as it is and taking sine 2 pi by 9 as a and cos 2 pi by 9 as b, then what we get? A square plus b square means sine square 2 pi by 9 plus cos square 2 pi by 9 divided by a plus iota b means sine 2 pi by 9 plus iota cos 2 pi by 9 whole cube. Don't forget to take whole cube, right? Now this is equal to 1 plus sine 2 pi by 9 plus iota cos 2 pi by 9 whole divided by, just take an LCM and simplify it. LCM is sine 2 pi by 9 plus iota cos 2 pi by 9. Here what we get? We get sine 2 pi by 9 plus iota cos 2 pi by 9 plus, see, sine square theta plus cos square theta is going to be 1. So this is equal to 1 and whole cube. Now see, this term and this term get cancelled and we get sine 2 pi by 9 plus iota cos 2 pi by 9 whole cube, right? Now can we use de Moivre's theorem here? No, we cannot use, because this number is still not of this form. So observe, this is an acute angle. So to convert it in this form, we can use trigonometric identities. The identity is cos pi by 2 minus theta is equal to sin theta and sin pi by 2 minus theta is equal to cos theta. So using it here, this is equal to cos pi by 2 minus 2 pi by 9 plus iota sin pi by 2 minus 2 pi by 9 whole cube, right? See, cos pi by 2 minus theta is sin theta and sin pi by 2 minus theta is cos theta. Now this is equal to cos, solving it, 9 pi minus 4 pi by 18, right? Plus iota sin 9 pi minus 4 pi by 18 and whole cube. Now we can use de Moivre's theorem here. So what should we do? Just multiply the power with the angle. So we get cos 3 into 5 pi by 18 plus iota sin 3 into 5 pi by 18, right? This is equal to cos 5 pi by 6 plus iota sin 5 pi by 6. This is equal to cos pi minus 5 pi by 6 plus iota sin pi minus pi by 6. See, pi minus pi by 6 against 5 pi by 6. So we can write it. Now we know cos pi minus theta is minus cos theta. So this is equal to minus cos pi by 6, sorry, pi by 6 plus iota. Sin pi minus theta is sin theta. So this is sin pi by 6. Now we know that cos pi by 6 is root 3 by 2. So this is equal to minus root 3 by 2 plus iota. Sin pi by 6 is 1 by 2. So this is 1 by 2. This is equal to minus root 3 plus iota by 2. So this is the required answer for this question. Hope you understood well. Thanks for watching this video. Thank you.